Hello, this is Mohammad Wakas, a mechatronics engineer. In this video, I have to show how the CPU works or what's inside the CPU. As you can see, CPU is comprises of uh, program counter or PC, instruction decoder to decode the instructions, ALU or arithmetic logic unit that is mainly responsible for the mathematical operations, and the registers for the storing or to store data. So how the computer works, this is the human readable code for our uh, for the age of humans, or for to understand. It has no concern with computer. This piece of code has, and this is the instructions to be executed or to execute for the CPU. As you can see, the I/O ports or I/O pins are connected to our CPU using address bus, data bus, and control bus, and our memory circuit is also connected to our CPU using the by address bus, data bus, and control bus. So in this, I will show you how the CPU or the computer works. So the program counter is stored value 0, that we have to execute the instruction at the 0th index in our memory or at the 0th location of our memory. So for when this will be executed, program will address bus will be given address 0. The 0th location will be accessed now, and we can see that 31H will be given to the instruction decoder using the data bus. Now the instruction decoder will decode this, and it means we have to place the data at 17th location, or at 17 IO, or to the point at point A. Sorry, this means we have to store the data at the 17th pin to the register A. So as we can see that now our program counter is also updated with one value. Now it will it is stored with a value 1. That means we have the next instruction to be executed is C4H. So when 31 instruction is decoded, our control bus will be in the read mode, as we have to read the data from the 17th IO, and physically or externally we have placed 9 at the 17th pin or 17th IO. The 9 will flow from the 17th IO to the used with the data bus, and will be stored at in the register A, as we can see this. No, we have to execute the instruction at the one location. So the program controller will give the address bus 1 address, and we can now access the C4H. No, in this step we have to add the data at the A to B. We have to copy the data from A and place it to the B. Now our control bus will be in the read mode. That is, we have to read the data from the register A and add to the B, or place at B. So the C4H instruction is fetched to the instruction decoder. The instruction decoder will decode this instruction, and further will be our program counter will also be updated to the 2, as we have to next execute the 26H instruction. So now 9 will be copied from A and be placed at B. So now our program counter has given the address to address bus, and we have access of the no we have the access of the to the instruction stored at the address 2. Now 26h will be given to our instruction decoder. Our instruction decoder will and our program counter will be updated to 3 as we have to next execute the problem instruction 81h. Now instruction decoder will decode the 26h, and this means we have to add the data at location 6 the register A. So address bus is given 6 address, and our control bus is in a read mode as we have to read the data from the location 6 and place it at at the A register. No, 5 as at the 6th location 5h is stored, so 5 will be flow from this using data bus and will be at our CPU, and our we after this the 5 will be placed or overwrite the register A will be overwrite with value 5, or that was a 6th location. No, our program counter gives address bus the address 3 as we have to execute the instruction 81h at 3rd location of our memory. Now 81h will flow from this up from our memory circuit to the instruction decoder, and our program counter will also be updated to the 4th, the next instruction to be executed, and the fourth operation or the 4th instruction we have to execute is 81h. This means that we have to add A plus B firstly and then place the result to the A, or we store the result to the in the register A. So this will be done by our ALU. As we can see that 5 and 9 will be added in the ALU and the result will be stored in the register A, that is E. Now our program counter will give the address bus the address 4. Now we have the access of EAH. The control bus will be in the read mode because we have to read the data. As you can see that the 4th instruction we have to execute is at the 7th location we have to place A. So what will be whatever is at the in the register A will be copied to the 7th location of our memory. Now firstly our control bus will be in the read mode, that it will be and EA we now we EAH EA will flow from our memory circuit to the instruction decoder. Instruction decoder will decode this instruction, and program counter will also be executed for the next instruction, and address bus is given the 7th address. As we can see, we have to add or we have to place the value stored in the register A to the 7th location of our memory. Now we are writing to our memory, and E will be copied from the register A and will be, and now our control bus will be in the write mode, and we will write this E to our memory location at 7th. So that is how computer works, or how the instructions are decoded, and how program counter works, what's the function of ALU, and why there are registers in the CPU. Thanks.